Hey guys, today I'm doing another AMC. This is from the year 2008. Yeah, the year I was born. I'm doing 2008 because I literally did everything after that. I did 2009, I did 2010, did 2011, up to 2021. I already did all of those. So, I wanted this to be a blind solve, okay? I don't want it to be something, oh, I already solved the problems beforehand. And so, okay, come on, let's start this. A bakery owner turns on his donuts machine at 8:30. Just to clarify, I'm going to explain everything in this video. So, of course, it's going to be substantially slower than when I actually do a test or when there's a time limit or something. Now let's do this. Donut machine at 8:30 a.m. It's 11:10 a.m. And the machine has completed one third of the day's job. Okay, let's see how many hours this is. Like 8. If this it's less than 3 hours, because it's not 11:30 yet. It's 3 hours minus 20 minutes. Yeah, I use 3 hours minus 20 minutes. Okay, now we moved this 3 hours then to 3 hours after. It will be 14. 10, but we minus 20 minutes. Yeah, that's how I do it. I don't even calculate this thing. Minus 10 minutes, 20 minutes, that's 1350. And then if we move, and then we shift this by 3 again, 16. Shift this down by 20, 16:30. Or, in other words, 4:30 p.m. D. Problem 2. What's the reciprocal of... Okay. When I do sword problems, I just literally imagine a pie chart in my mind. Come on. 1/2 plus 2/3. Oh yeah, this is 2/3. 1/3, 2/3. Then you can see this goes on 1/2 one whole and pokes out here. It's 7/6. So the reciprocal is 6/7. 8. Suppose that 2/3 of 10 bananas are worth as much as 8 oranges. 2/3 of 10 bananas. 10 bananas are worth as much as 8 oranges. How many oranges are worth as much as 2/2 of 5 bananas? Then this is 3/20 equals B equals 8O. This isn't, I should have used O. Okay, let's pretend this isn't a 0. Okay, this isn't an 80. This is 8O. And you're supposed to know that? Yeah. We multiply both sides by 3. You get 20B equals 8 times 3. I'm not even going to calculate this because, yeah, whatever. We divide this by 4, we get 5, and then we divide by another 2, then it's 1/2 of 5, right? If you want to get 1/2 of 5, then it's 1/2 of 5B equals, now, just know 8, right? The factor here is 8, so we divide by 8 on both sides. Now get 3O, so the answer is 3. See, problem 4. Which of the following is equal to the product of 4 times 8 times 12? Yeah, this cancels out. This cancels out. This all cancels out. Bam, 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 until here. This cancels out. So it's 2008 divided by 4, which is obviously this, 502. Suppose that this is an integer. Okay, it's less, this turn this into one big fraction first. It's because these two might both not be integers, but this difference might be an integer. So that's a mistake some people like make. Yeah, like people who aren't that good at math might make this mistake. Not me though. Let's see, this 3, then we turn into the 6, and we multiply this by 2, multiply this by 2 as well. This is 4x minus this x. Well, 2/3 minus 1/6 is 1/2. Alright, this is 6/3. This is, see? And it's half of x. So if this is an integer, then x must be even. It is even, but not necessarily a multiple for 3. Yep. Heather compares the price of a new computer at 2 different stores. Store A offers 15% off the sticker price. Okay, followed by a 90% rebate. And Store B offers 25% off at the same sticker price with no rebate. Heather saves $15 by buying the computer at Store A instead of Store B. What's the sticker price of the computer in dollars? Okay, let's see. The sticker price of the computer is C. Okay, C for computer. Also because C is the best letter. Nobody challenges. C is the best letter. It's not useless or whatever. Store A offers 15% off the sticker price. Alright, so if it's 15% off, then there's 85% that's not off. Followed by 9% rebate minus 90. Heather saves. This is the Store A price. Now Heather saves $15 by buying the computer at Store A instead of Store B. Yeah, so Store B is like $15 expensive. $15 expensive than Store A. So the Store A price plus $15 will equal the Store B price, which is, well, 75% C. Bring this over to this side. We bring the constants over here. And then there we have it. 10% C equals 75. So basically 10% C is 10, C over 10 is 75 times our C will be 750. A. Okay, problem 7. While Steve and Leroy are fishing 1 mile from shore, their boat springs a leak, and water comes in at a constant rate of 10 gallons per minute. The boat will sink if it takes in more than 30 gallons of water. Steve starts rowing towards the shore at a constant rate of 4 miles per hour, while Leroy bails water out of the boat. What's the slowest rate the gallons per minute at which Leroy can bail if they are to reach the shore or without sinking? Now, they're asking for the slowest rate, which means the ship will, which means the boat will sink just just as it reaches the shore. The boat almost sinks just as it reaches the shore. So it means the boat would have 30, boat starts to sink, boat will start to sink, then reaches the shore. So the boat would have 30 gallons of water when it reaches the shore. Okay, now see. They're fishing 1 mile from shore. They start rowing toward the shore at a constant rate of 4 miles per hour. So 4 miles per hour. Then it's 1 mile per 1/4 of an hour, which is 50 minutes. So it took 50 minutes for them to get to the shore. Now during the 50 minutes, there will be 30 gallons. The boat takes in 30 gallons of water. So it takes in two gallons per minute. Okay, it takes in 2 gallons of water per minute overall. Now, the water actually comes in at a constant rate of 2 gallons per minute, which means Leroy bails out 8 gallons per minute. So D. What's the volume of a cube whose surface area is twice? Okay. Area is twice that cube with volume 1. If the circuit what? If the surface area is double, then surface area is squared, right? So the base dimensions would be this. Surface area is twice. This is the base. Then the vertice length will be √2. So the volume will be. Anyways, next question. Older television screens have an aspect ratio of 4:3. That's the ratio of the width to the height is 4:3. It's 4:3. The aspect ratio of many movies is not 4:3, so they are sometimes shown on television screen by letterboxing. Darkening strips of equal height to the top and bottom of the screen as shown. Suppose a movie has an aspect ratio of 2:1. So this is you can divide it into two squares like this. That is shown on an older television screen with 27-inch diagonal. 27-inch diagonal. What's the height in inches of each darkened strip? Okay, so this 3, this 4, or this will be. This is 3x, this is 4x, this will be 5x. 5x equals 27, x equals 27. Okay, now see here. This is 2:1. But this is 4. 2:1 is equal to 4:2. This is 4:3. Oh wait, this is half of 4x. This is going to be half of 4x, which is 2x. Now, this whole thing is 3x. So it's this 3x minus 2x is just x. Okay, this plus this is x. So each of these dark strips the height of each of these dark strips is half of x. Now we know x is 27 over 5. Half of x is going to be 27 over 10, which is 2.7, of course. Problem 10. Doug can paint a room in 5 hours. Dave can paint the same room in 7 hours. Doug and Dave paint the room together and take a 1-hour break for lunch. Let T be the total time and hours required for them to complete the job working together, including lunch. Which of the following equations is satisfied by t? If Doug can paint a room in 5 hours, then the speed of painting will be 5 or 1/5. Dave's speed will be 1/7. 7 days paint the same room together and take a 1 hour break for lunch. If they paint the room together, then their speeds would add up. So it's this, right? They take a 1 hour break for lunch. Let t be the total time in hours required for them to complete the job working together. Now the t contains that lunch break. We have to remove the lunch break because they're not working then. So we have to take away one. We need to take away 1 from t, okay? So this is t minus 1 now. Now these are the working hours. Now our time speed. Now times speed. We assume that now time times speed equals the total work done. Now the work done is represented by 1 because this is 1 divided by 5, 1 divided by 7. This 1 represents the work done, okay? So this times the work hours, which is t minus 1, is equal to the work done, which is 1. Which is the one room they needed to paint. Okay, problem 11. 3 cubes are each formed from the patterns shown. They're stacked on a table, one on top of another, so that the 13 visible numbers have the greatest possible sum. What is that sum? Okay, 13 visible numbers. Of course, the cube has 6 sides. So like this. Sorry for the bad diagram. I am bad at drawing on a word that's not paper. Well, that's how they're stacked, right? Each of the bottom 2 cubes sacrifice 2 sides, while the top cube sacrifices only 1. Well, we sacrifice only 1 side. Obviously, if we want the greatest possible sum, we will sacrifice the 1. All right. Now, for the ones to satisfy 2 sides, we have to consider the relative positions. Now, when we sacrifice 2 sides, it's not just any 2 sides, it's the sides that are directly opposite each other. If we sacrifice, so it's either 1 and 32, 2 and 60, or 4 and 8. If 1 is 32, that will be 2, that will be 33, 2 and 60. That would be 18, and 4 plus 8 is 12. Well, I guess we now know what to sacrifice. Y'all now know what to sacrifice, right? We need to sacrifice the 4 and 8 to produce 8. Because that's, we sacrifice the 12. Because we don't want to sacrifice an 18 or a 33, right? We sacrifice 2 12s and the 1, which is 25. Okay. Now, the original sum, where all this stuff adds up, This is all the powers up 2, including the 1, added up to 32, so it will be 64 minus 1, 63. It's 63 times 3 minus 25. Okay, now what is that? 63 times 3 is 63. 189 minus 25 is 164. That's fine. A function f has domain 0, 2 and the range 0, 1. The notation AB doesn't know this. What are the domain and range respectively of the function g divided by Okay, let's see now. We draw this graph. Honestly, I could have removed these. Move this all the quadrants beside the first one, but I'm not going to. I'm going to include all the quadrants here, okay? Mainly because of gx. Because of gx. Now say this is x, this is y. Here just say fx, this is x, fx, this is 0, this is 1, this is 1, this is 2. This means that the graph of x, fx, the test domain is going to be inside of this box. It's going to be trapped inside this box. It won't go outside the box, ever. Now gx equals 1 minus fx plus 1. Okay, first let's talk about fx plus 1. What would this thing's graph look like? We know fx here has a domain of 0, 2, so 0. But now this is fx plus 1, so instead of x here, we read x plus 1. In fact, whatever's in this parentheses is going to belong here. Oh, right, it's 2. Which means, if we draw a graph, the range of this function would be -1, x, 1. We just take away 1 on all these. So now it becomes this box. Because it's still f, the value of this thing doesn't change, it just shifted to the left by 1. Now gx equals, now this also has a factor. We multiply this by a factor of -1. This became a negative. So all of the values of x will be negative. Its range will also become the negative. So we move the box here. Now gx is equals to 1 minus this thing. And this is mine. You have this box way out. Now there's the 1. We add 1 to this entire box. We add 1 to this box. Of course, it's a final value, so we move this up by 1 again. And we're back to the breadbox here. This is going to be the domain range. The domain is from here to here, -1 to 1, while the range is still 0 to 1. B. Problem 13. Points A and B lie on a circle centered at O, and AOB equals 60. I suck at drawing circles, by the way. This is not a circle. This is an oval. Come on. I suck at drawing circles, especially when it's not on paper. If I was paper, this is not paper, then, well, you would get something like this. This is what I would end up with. This is the center, I think. O. Now we have to use it for color because it's so... $60. Now, of course, this is a special angle. We probably would like to use this later on. So just remember, this triangle is equilateral. This is the equilateral triangle here. A second circle, A, B. The second circle is internally tangent to the first. It's tangent to this circle and also tangent to both OA and OB. So let me draw this here. It's going to go here. Alright. It's tangent to this. It's tangent to both this line, this line. We extend this out, and also this line. Of course, this is still an equilateral triangle, just with different dimensions. Now, the ratio of the area of the smaller circle to that of the larger circle is basically this, the area of the radius. Let's call this one, this point is P. R. The area of the small circle, area P, divided by area O, because that's what a ratio is about, is equal to the radius of P, radius of O squared. Now, you know, there's also this pi and pi, this pi radius squared. Yeah, the pi's got canceled out. Anyways, now the radius of this line is this. Of course, you know, since this is an equilateral triangle and the radius of this triangle is going to be 1/3 of the height of the triangle. It's 1/3 of the height because, well, equilateral triangles. Now the height here is equal to the radius of the big circle. So basically, we just established that our P equals 1/3 of this height, which is RO. Now we studied, so we can say that 3RP equals RO. Now we can sub all the ROs for RP. PE here, then so it gives us this ratio, 1/9. Problem 14. What's the area of the region defined by the inequality? 3x minus 18 plus 2y plus 7. This all absolute values smaller than is 3. Is smaller than 3. Yeah, abstract. No, not abstract. Absolute value questions. It's 3x minus 18, huh? So when does this equal 0? It's when x equals 6, right? Now when x is smaller than 6, this will be negative. Now, that means if when x equals 5 and when x equals 7, this will both be, and the values will be negative. This is linear, so it's symmetric. It has symmetry. I mean, it used to be rotational symmetry, but because of this abstract value, the rotational symmetry just became reflectional symmetry. Well, it's a good thing it didn't become false symmetry. why I make that joke? X equals 5, x equals 7, and they'll yield equal values. When x equals 4, x equals 8, they'll also yield equal values. So actually, so of course, if a point where x equals 5 is in the region, then the same point, then the point with the same y coordinates, but with x equals 7, it will also be in the region. Similarly, if the point where x equals 4 is in the region, then the same point where the y doesn't change, but the x is equal to 8, that point will also be in the region. So basically, we just established that this region is has reflectional symmetry over the line x equals 6. Now that's going to be extremely useful for this. We basically just tackle one of these abstract. Why do I keep saying abstract value? It's absolute value, not abstract value. No, usually since I do programming stuff, most of the time when I see abstract value, it's just ABS. So, absolute value, I mean ABS. So, and the first thing I thought when I see the letters ABS is, well, abstract. That's the first word that comes to my mind. So, yeah, you get it. To say this is 1, 2, 3, 4, 5, 6. Okay, so this is an important line of symmetry here. Anyways, now I have 2y plus 7. 2y plus 7. When does this equal 0? It's when y equals negative this, right? So, by the same logic, this should also y equals negative, sure, 7 over 2. That's also a line of symmetry. I have to read them. X equals 6, y equals. Okay, now we have established this thing. This whole thing is smaller than or equal to 3. now it can just do one quadrant, and the other quadrants will just appear and then multiply by 4, right? We could do one quadrant, 3x minus 18. We're assuming that we're doing this quadrant, which means both of these are positive, which means x is greater than 6 and y is going to be greater than negative 7 over 2. Negative 3.5, negative plus 2y plus 7 is smaller than 3. So this becomes 3x plus 2y is smaller than or equal to 14. Which then goes to y is smaller than or equal to 7 minus, okay, 1, 2, 3, 4, 5, 6, 7. We draw the graph of this line. Okay. Actually, we don't even need to do the y equals, let's say x equals 0, then y is 7. 1, 2, 3, 4, 5, 6, 7. Now, when y equals 0, then 3x is less than or equal to 14. So x is 14 divided by 3, which is almost 5, but with 1/3 short. So there you have it. We have our line. Now, of course, we know this is in the first quadrant, so we're only counting this area here. Meanwhile, we can construct a rhombus out of on the other. There we have it. We have our region. Now, anyways, we calculate the intersections of these two lines. We just plug x equals 6 into here, and we will get y equals negative 2. Similarly, we could plug this in there. We will get x equals 7. This 6, this is 7. And this is 2, this is negative 2. Negative 2. This would be, the difference here is 1.5, while the difference here is just 1. So the area of this triangle is this. Now the area of the whole rhombus will of course be this, because you multiply by 4. Next problem. Let k equals 2008 squared plus 2 to the 2008. Okay, what's the unit digit of k to second plus 2 to k? So this is number theory. Let's see. Now, if a number's unit digit is 2, then its square will have a unit digit of 4, and its cube will have a unit digit of 8, and then its fourth power will have a unit digit of 6, and its fifth power, it would be 2, 4, 8, 6, 2, 4, 8, 6, so on. Now, this is 2 to the 2008. It's a multiple of 4. Now, for every multiple of 4, the units digit would be, well, 6. So this has a unit digit of 6. Or six. Now what about this? This is 8. Now 8 squared is 64. The unit digit is 4. 8 cubed is, well, 512 2, and then of course we times the 2, we times it again, 2, 8, 16, 6. It's the same pattern, but like backwards. And starting from 8. 1, 2, 3, 4. Now this ends in 8, so the square would end in 4. The square would end in 4. Wait. It equals 4 plus 6 mod 10. So K, which basically means that K is a multiple of 10 equals 10. 4 plus 6 is 10 mod 10, which is, of course, 0 mod 10. So its unit digit is 0. Okay, but now, so now k to the squared. K squared would also have a unit digit of 0. But 2 to the k's power. Now, how do you make that work? We have to know we have a mod 4, not mod 10. So we have to do this whole thing again. But this time in base 4. Now, of course, this is more easier than you think. Since 2008 is multiple of 4, it will end in 0 in base 4. So this will be 0. Okay, you have to do this thing in base 4 or this mod 4. Since this is multiple of 4, it's gone now. It's 0. And meanwhile, this is also 0. Why, you ask? Well, this is 2008 is a multiple of 4. Actually, I'm just going to 4. Actually, it's just multiple of 2 would do. Let's have other 4. 2. Now, 2 squared. You know what that is, right? It's 4. Is equal to 0 mod 4. So this thing is 0 mod 4. This thing is a multiple of 4, which means this ends in 6, and this ends in 0. So you add them together, the whole thing would end in 6. D. Problem 16. The numbers log a to 3, a to the third, b to the 7th, log a to the 5th, b to the 12th, and log a to the 8th, b to the 15th are the first 3 terms of an arithmetic sequence. And the 12th term of the sequence is log b. Okay, since there are the first 3 terms of an arithmetic sequence, this is the logarithmic scale. This is an arithmetic sequence, and that is what you know what that means. That means a 3, b to 7th, a to 5th, b to 12th, and a to 8th, b to 15th, 18th. They're going to be part of a geometric sequence. Logarithms. Yay, logarithms. Now this this times what equals this? Well, a to a squared b to the fifth. Now this times what is this? A cube b to the third. What does that tell us? It tells us these two are equal since this is a geometric sequence, which means a equals b squared. Yeah, we just divided this whole thing by a squared b cubed. So now we get a equals b squared. So in fact, we can replace all of this, these a's with b squares. So this will be b to the 13. This will be b to the 22nd. This will be b to the 31st. Okay. In fact, we could just say that the mth term is equal to b to the 13 plus b to the 4 plus 9m. Like the first term is going to be 4 plus 9, 13. The second term is 4 plus 18, 22. The second is, yeah, you get it. What is n? The 12th term of the sequence would be 4b to the 4 plus 9 times 12. 9 times 12 is 108 plus 4, that's 112. So, D. Problem 17. Let A1, A2, etc. be a sequence determined by the rule AN equals AN minus 1 divided by 2 if AN minus 1 is even, and AN equals 3, AN minus 1 plus 1 if AN minus 1 is odd. Well, I think this sequence is kind of familiar. Oh yeah, I just looked it up. It's the collapse. It's the collapse sequence. It's the collapse sequence. It has this sequence. Let the sequence that's determined by the rule AN, or how many positive, and there's a conjecture or an unsolved conjecture involving this, which means which states that for basically any A1, any integer A1, it could positive integer A1. It would be 1, 2, 3, 4, blah, 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 blah. This sequence would always contain 1. The sequence will also always eventually reach 1. But that's kind of off topic since that's not the problem we're trying to solve here. We're trying to solve this. So this term by rule, this is for how many positive integers A1 so that A1 is less than each of A2, A3, and A4. If we want A1 to be less than A2, then A1 has to be odd. Because if A1 is even, then A2 would be half that, which would be, and so it would be smaller than that. So A2 would also have, now A2, it doesn't really matter. Now we can split this into two cases now. A2 is odd or A2 is even. Well, A2 can be even because, well, A2 would then A3 would just be half of A2, but half of A2 is still greater than bigger than A1. I mean, it's half of this. Half of this is definitely bigger than the original A. So A2 can definitely be even, but A3 would then have to be odd because it's odd with two evens. Is gonna because then because if A2 and A3 are both even, then A4 will be smaller than A1. You can prove this. Well, this I'm just using my intuition here. Then if A1 and A2 are both odd, then A3 can be either odd or even. So odd, even, and odd, even, odd. We want this kind of sequence to occur. Okay, so let's erase all of this. See. Odd. The first type, odd. Basically, A1 is odd, and A1 times 3 A1 times 3, which is E plus 1 will also be odd. But wait, no! How? That's literally not possible. Not possible. Because, well, 3A1 will also be odd, so it is plus 1. It's going to be even. Yeah, in fact, we could also dismiss odd, even. In fact, that only leaves us with the odd, even, odd. There can't be any consecutive odds in this sequence, and I know that. There can't be any consecutive odds. Odd, even, odd. This is like the only possibility. There can be consecutive evens though, but not consecutive odds. Now, let's see. Odd, even, odd. Now this means this is A1. A1 is odd. Of course, A1. Now A2 will be A1 times 3 plus 1. Now A3 will be this, then divided by 2. So this would also be odd. So yeah, we just simplified the problem to this. A1 is odd and this thing is also odd. Now we should calculate the value of. Let's compute the value of this for all the odd numbers. Okay, let's see if we can find a pattern. Just ignore the problem putting 8 down. This is 18 down there. Okay. 1, 3, 5, 7, 11, 13, 15, 17, blah, blah. Okay, let's compute this. 3 times 1 is 3 plus 1 is 4, 2, 2, 2, okay, 3, 9 plus 1, 10, 5. 5. 3 times 5. 5 is 15 plus 1 is 16 divided by 2. That's 8. In fact, yeah, I know we could just continue the sequence, right? It's 3. We don't even need to compute anything more. Well, we could do 3 times 7. Wait, 1 plus 1 is 22. This is 11. And then 14, 17. Yeah, you get it. So for each of these 3, so we want these. We want these 3, 7, 13, 17. We want these was all satisfied it. The thing. Wait, what? I think okay, where's 9? 9, okay, 7, 8, 9. 7 literally 8, 9. Like, I suddenly guess 3, 5, 7. And what's next? 11. 11. Well, I encountered primes a lot, so yeah, I actually didn't really sorry about that. That 7, 8, 9. Okay. 7, 7, 8, 9. Then it's 7. Why do you have to do that? 15, this 20, 23. 26. 7 just barfed 9 out. And now we have this actual. 3 satisfies this. 7 satisfies this. 11 satisfies this. 15 satisfies this. And this. Yep. See how it's all multiple. All the 4s minus. Multiples of 4 minus what? 4 and minus what? Numbers. Now this is a multiple of 4, which makes it easy. There's only one, and 4 minus 1 integers from 1 to 4. There are 2 4 minus 1 integers from 1 to 8. In fact, you just divide this thing by 4. It's 502. Okay, problem 18. A triangle ABC with sides 5, 6, 7 is placed in the three-dimensional plane with one vertex on the positive x-axis. One on the positive y-axis and one on the positive z-axis. Wait, hold on. Hold on. What? 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 I don't get this question at all. Okay. What's this three-dimensional play? What's a three-dimensional play? Hey, what are the positive x? What are the positive y? What are the positive z? How could that even make a triangle? Okay. Hold on. I need a moment to think. Okay, okay, fine. I think I just confused the I think I just confused vertex and size. Size. I got them mixed up. I got the words mixed up. Well, I'm not. I'm not a native English speaker, so I'm not a native English speaker. I never learned math. I didn't learn math in English. I learned math in Chinese, so I did. I sometimes forget the meanings of all these words and stuff. Yeah, vertex means the points, not the lines. The vertex is the points, not the lines. How did I'm actually getting that confused. Oh my god. I'm so stupid. Anyways, let's draw this graph. Okay, this is X. This is Y. This is Z. Ignore this problem 19 thing poking out. And then why did I draw the graph so big anyway? Let's see, this is 5, 6, 7. So the measures are 5, 6, 7. We say, let's make this the 5. Make this the 6. And this is 7. Okay, this is O. What's the volume of OABC? Okay, now this is easy. We say this is X0, this is Y0, this is Z0. X0 plus Y0 equals 5. Y0 plus Z0 equals 6. Z0 plus X0 equals 7. Actually, we square out that because Pythagoras. So according to Pythagoras, we have these sets of equations. We add them all up and divide by 2 to get. This is 25, 36, 49. We add them all up, we could get. This is 11. We get 110. But then we divide by 2 to get 55. Alright, so of course then we can get the individual then. So x0 squared would be this minus this, 19. Y0 squared is this minus this, which is 6. And Z0 squared is this minus this. 30. So the volume of this tetrahedron is 1/6 of x0 times y0 times z0. Z0 is equal to 1/6 times root 90 times root 6 times root 30. Okay, root 6 times root 30, that's root 180, which is equal to times 6 times 90 times root 2. Root 5. Root 5 is 30 is 6 times 5. These two make 95. These two cancel out. So the final answer will be C, root 95. Let's look at problem 90 now. It's an expansion of this. What's the coefficient of x to the 28? Okay, let's break this down first. This is squared one, should be easy. Now, be 1 plus x squared plus x fourth plus x6 plus blah 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 plus x to the 28th. Now we will also have d. Now these are the only stuff in here. We will also have pretty much all the other combinations. In fact, this is about combinatorics, people. Now, this is, there are a lot of combinations we can use to make actually first 0, 0 and 27, and by 27 I mean x to the 27, and by 0 I mean x to the 0, which is this one over here. Yeah, we could we just use this 20. Yeah, there's an x 28 in here obviously, and we times this one. Oh, we get something like this with a coefficient. Now, obviously, all of this just has a coefficient of 1. So, we only need to worry about all of the coefficients in here. In fact, also, you notice how all of this, we square this, none of the exponents would get past 28. So, there's always something to combine with over here. But all besides that 1. The 1 doesn't have anything to combine with because, well, if there's a 1, then we'll have to combine with the next 28 to create something like this. And that is, my folks, is not possible. It's not possible at all. Now, since Since multiplying with any of these doesn't change the coefficient, what we're looking for is basically the sum of all the coefficients in the expansion of this. Besides besides that one, besides the one, we don't add the one. We do not add the one. We don't add up the one. No, the one doesn't count. Okay. All should add it up. Well, I can do count one as a coefficient. Well, I can. Some people does, some people don't. But when we're actually calculating this, is we're gonna have to remove it either way. So let's say we counted it to make it life for easier. Well, actually, it doesn't have a difference. It doesn't make a difference at all. All coefficients add up minus that term, minus the one. So the first, so of course we have to expand it. First we will have 1 plus x this squared plus this squared plus this squared blah 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 plus this squared. Of course this is the first part. All of that added up is just, once again we do not count this one, so yeah, we don't count this. All the coefficients here add up. That's just 14. And there's also the 2 something something part. 2 times 1 times x plus 2 times 1 times x squared plus x 2 times 1 times x3. There's all 2 times x plus x. In fact, this would be a whole lot easier if we just didn't do it this way. We could just do it as plus x 14 times now obviously if we multiply one of these by one of these, the coefficient would of course be 1. So each of these counts as a 1. So no one is suggesting each of these counts as a 1. Now there are 15 choices over here, 15 choices over here. So that means the total number of everything. We're not going to combine any of this stuff. We'll make the coefficients 1, leave them be. That would be 15 times 50, 225 possibilities. So all coefficients add up will be 225. Of course, we need to minus the ones. We take away one, take away one, take away one. I'm so silly. So this is the answer, 224, because that's 1. And 1 times 1 doesn't count. Anyways, I think that should be it for now. Now, I'm going to do 20 questions, problems 20 to 25 in a separate video. Also, I think this is pretty easy compared to AMC nowadays. This is easier than like the 2021 or 2022 AMC, to say at least. Well, it's in the old an old version, so yeah, I guess it makes sense. I might do the 2022 AMC soon. But for now, let's end this here.